Okay, let's start the class. See, write down the question, write down the diagram. Draw the circuit. Is it audible? Hello?
Yes, sir.
Yes,
It's
sir.
audible.
It's audible. It's audible.
Okay. So we are doing the problems on Norton's theorem. Today we'll see two more problems on Norton's theorem. Draw the circuit. Okay. Determine the current in 5 ohms. Determine the current in 5 ohms using Norton's theorem. Determine the current in 5 ohms using Norton's theorem. So first what you have to do? In Norton's theorem, first what you have to do? Anyone?
First, we need to
short circuit the way we have
short
to
circuit the short circuit at the 5 ohms.
5
5
ohms.
ohms. Yes, sir.
Had short circuit the 5 ohms. ISC is the short circuit current. Okay. Now I had to determine this Norton current or short circuit current. So anything which is any resistance which is in parallel with the short circuit, what will happen? Any resistance which is in parallel with the short circuit, what will happen? What is the resistance in the short circuit?
5, sir.
No. Short circuit. After short circuiting. Short circuit lo resistance unda akkada?
No.
0. In after short circuiting, your resistance is 0 in the short circuit.
0, sir.
Okay. Resistance is 0. Now see here, anything which is in parallel with the short circuit, this will not work. This resistor will not work. Why means, see these two parallel, determine the equivalent of this 0 in parallel, 0 plus 10. What is the equivalent resistance?
0, sir.
0. That means write down note point. Any resistance which is in parallel with the short circuit will not work. Any resistance, write down. Any resistance which is in parallel with the short circuit will not work. Right on. Any resistance which is in parallel with the short circuit will not work. Okay. Draw the circuit. Have you drawn? If you have drawn, tell me. I will proceed. Okay. See here. Now I have removed the now I have removed that resistance. Now we have to determine ISC. Any resistance which is in parallel with the short circuit, that will not work. Now I will determine the ISC. Now we can apply nodal analysis or mesh analysis, whatever you want to apply, you can apply. Okay. What you can apply? Mesh analysis or nodal analysis for determining ISC. Shall we apply mesh analysis? See here. Two loops are there. Here closed path is there. Let us take I1 and I2. What is your I2? I2 is equal to ISC. Your I2 is equal to ISC. Now I want to determine I2. Once if you determine I2, that is equal to Norton current or short circuit current. Write the matrix 4 plus 4, 8. 4 plus 8, 12. And 4 and this 4 is common to both the loops. Minus 4. This is also minus 4. This is the common element. I1 is in the downward direction, I2 is in the upward direction. That's why I'm taking minus. A11 means sum of all elements in the first loop, 4 plus 4. 8 plus 4 is 12. I1, I2. What is in the first loop we are having 20 volts. Now I want I2. I2 is equal to delta 2 by delta. Your delta 2 is replace the second column with voltage sources. So your short circuit current or Norton current is 1 ampere. Your short circuit or Norton's current is 1 ampere. I am determining only I2 because I want ISC. I2 is equal to ISC, short circuit current. Now I will determine the equivalent resistance. Have you completed? Have you written?
Yes, sir.
Sir.
Okay. Now we'll go for the RN, Norton resistance. In Norton resistance, what do you have to do? So I'm drawing for determining RTH or RN, we have to short all the voltage sources. We have to short all the voltage sources. Now, if Rn is this side, we have to calculate the equivalent value from the opposite side. See here, 4 and 4 are in parallel or series.
Parallel.
Parallel, sir.
Then what is the equivalent of 4 and 4? 2 ohms. 4 into 4 by 4 plus 4. It will be 2. See, it will be 2. 4 and 4 are in parallel, in series with 8, in parallel with 10. Rn is equal to 4 and 4 are parallel. This will be 2. This will be 2. See, now 2 is coming in series with 8. This 2 is coming in series with 8. Now 10 and 10 are in parallel. Your Rn is 5. Your Rn is equal to 5. Okay. 4 and 4 are parallel, in series with 8, in parallel with 10. This is your Rn. Now see here. Now I will draw the equivalent circuit. Norton current. In parallel with Rn. IN is 1 ampere. This is 5 ohms. What is the resistance we have removed here?
5 ohm.
What is the resistance we have short circuit? How much?
5 ohms.
5 ohms? Okay. 5 ohms. Now I want to determine the current in this 5 ohms. Therefore, this IN is coming here. Apply current divider. I want the current in this branch. Current in 5 ohms is equal to total current. Total current is Norton current. What is the opposite branch for 5 ohms? For this current, I want to determine the current in 5 ohms. Let us take I is the current in 5 ohms. I is equal to current in 5 ohms is opposite branch is Rn. Rn by Rn plus 5. That is 1 into 5 by 5 plus 5. 0.5 ampere. In this way, we'll determine the current in 5 ohms using Norton's theorem. If you want to verify, you can verify at home by using mesh or node analysis to the actual problem. Now we'll go to the next problem. Determine the current in 6 ohms. Determine the current in 6 ohms using Norton's theorem. Determine the current in 6 ohms using Norton's theorem. Determine the current in 6 ohms using Norton's theorem. Okay, first what you have to do? What do you have to do? For determining ISC, what you have to do? Short circuit current or Norton
Determine
current?
short circuit there.
Short circuit, sir.
Which one?
At 6 ohms.
6
Which
ohms.
resistance? 6 ohms. See here, I'm short circuiting this 6 ohms. I have short circuited. Now this 10 and 2 are in series or parallel? 10 and 2 are in series or parallel?
Parallel, sir.
See properly. This is only one branch. If current
2 are
divides,
in
they will come
series,
in
no?
parallel.
Series, sir.
If the
Series.
current is dividing, they will come in parallel. But 10 and 2 only one branch.
Sir, your bandwidth is low. It's not visible.
Yes, sir.
One minute, one call is coming. Hello, is it visible now? Hello.
Yes, sir.
Okay. See here, 10 and 2 are in series. Now this 10 and 2 can be written 12 ohms. 10 and 2 can be written 12 volts. Sorry, 12 ohms. Now, in the previous problem also I had told, any resistance which is in parallel with the short circuit, what will happen? It will not work. Because resistance here is 0 in short
Yes,
circuit.
sir. It will.
0 into 12 by 0 into 12 by 0 plus 12, R1, R2 by R1 plus R2. Any resistance which is in parallel with the short circuit, it will not work. Okay. Remember this point. Any resistance which is in parallel with the short circuit will not work. Okay. Now I am removing this resistance. Now draw this circuit. The 12 ohms will not work. I had told the reason also. Any resistance which is in parallel with the short circuit will not work. In short circuit, your resistance is 0. Now I had to determine. Now I had to determine short circuit current. Which method is easy for applying? For determining ISC? Which method is easy? Mesh analysis or nodal analysis or current divider? By seeing the problem, you should know.
Divide rule.
Huh?
Current divide rule.
Current divider. Because only two resistances are there and current source is here. This current will divide here. This 12 ampere will come here and it will divide in these two branches. I want the current. ISC is the current in 4 ohms. ISC is equal to total current into, what is the opposite branch for ISC?
8
What
ohms.
is the opposite branch for ISC?
8 ohms. Sir.
8 ohms, sir.
8. 8 by 8 plus 4. That is equal to 8 ampere. That is your short circuit current. That is your short circuit current. Okay. Now I have to determine RN, Norton resistance. See how to determine Norton resistance? For determining Norton resistance, what you will do? What you will do for determining Norton resistance? What you will do for determining Norton resistance? We will short all the voltage sources and open all the
current source.
here
All the
only
current.
current source is there. So I am opening this current source. I am opening this current source. Now I determine RN. Now tell me. Now tell me what is RN? What about 8 and 4? How they are? In series or
They are
parallel?
series.
Series. 8 and 4 are series.
In parallel with 12.
In parallel with 12. That is your not on it. If two resistors are same, if two same resistances are in parallel, it will become half. If you want to determine, you can determine. If any two resistances or equal resistances are there in parallel, that will be half. 12 and 12 are parallel, that is 6. If you want to determine R1, R2 by R1 plus R2, you can determine that. Okay, now we'll go for in the problem he is asking us to determine the current in 6 ohms. So I'm drawing the equivalent circuit. What is the resistance we have removed, we have shorted there in the problem? What is the resistance we have short circuited?
6 ohms, sir.
6 ohms. Therefore, current in 6 ohms I want. Current in 6 ohms is equal to total current into opposite branch. That is, I want the current in 6 ohms. Okay. Opposite branches Rn divided by total resistance of parallel branches. Total resistance of parallel branches. We know In and Rn. We can determine the current in 6 ohms. What is the value of current? How much you got? Hello? Hello? What is the value you got? Hello?
Yes, sir, you're audible. We're just doing it. Just a minute, sir.
Okay, no problem. You'll get 8 ampere, I think. Determine the current in 6 ohms using Norton's theorem. Determine the current in 6 ohms using Norton's theorem. Determine the current in 6 ohms using Norton's theorem. Determine the current in 6 ohms using Norton's theorem. What I had to do first step?
Short circuit 6 ohms.
Short circuit 6 ohms. And I will write here Norton current or ISC. Both are one and same. Norton current or ISC. So for determining I2, I am applying mesh analysis. See, I have written the matrix. If any wrong is there, you can tell me. If I have written wrong, you can tell me. Calculate and tell me you have to get I2 is equal to 1.25 ampere. You should get I2 is equal to 1.25 ampere. I2 is equal to delta 2 by delta. Calculate and verify. You know how to calculate I2. I2 is equal to delta 2 by delta. You should get that. In your textbook, they have given 1.25 ampere.
Yes, sir. 1.25 ampere. 40 by 32.
Okay. So now we have determined short circuit current. Your I2 is equal to short because see the direction of IN and I2 both are same. Therefore, IN is equal to your I2. There is no need to calculate I1. We don't want I1. We need only I2.
So, but we are getting negative 1.25. Is that okay?
Negative or positive? Verify.
I got negative.
Turn negative.
Anybody else, if they got positive?
Turn negative.
Okay. Then it will be negative. If it is negative, okay. In textbook also they have changed the direction. That means it is negative. In textbook they have given like this. Arrow is given like this. Downward they have given.
Okay, sir.
That is 1.25 they have given, and arrow is given downward. That means what is the meaning of this is in textbook? What is the meaning?
That downward is not visible, sir.
Okay.
Yes, sir. Okay.
See here in your textbook, they have taken it as positive, sorry, negative, and the arrow is downward. Why the arrow is downward? Because if current is moving away from, for a positive direction, what you have taken? You have taken the upward direction. If you are getting positive, we have taken the upward direction. If you are getting negative, they have taken the downward direction you are taking. That's why they have taken here positive. Actually, you will get negative. That negative has to be represented in the downward direction, in this direction. Now, what is Rn? We have not calculated. For determining Rn, what you will do?
Open circuits and short circuit or voltage.
Yes, there are only voltage sources. There are no current sources. I am shorting all the voltage sources. 3 voltage sources are there. 1, 2, 3. 3 voltage sources are there. If Rn is this side, calculate from the opposite side. That is, your 4 and 4 are in 4 and 4 are in parallel in series with 2.
So minus 0.5.
Okay. Actually, it is plus only. Why it is
Okay,
plus?
sir.
If current is in the downward direction in 6 ohms, it is minus. If current is in the upward, it is plus 0.5. Okay.
Okay, sir.
If you consider the opposite direction, it becomes minus. Okay. Now I'll take the attendance. Wait for some time.